This is an overview of Chapter 6 about the network layer in CIST 2451. We're working with the network layer. The network layer does 4 items. First one is that we address our end devices. We use IP addresses for that. And this is going to be the address of the ultimate ends, as opposed to down on the data link layer is from device to device. So we put the original IP address on there as the source where it actually started out from, and then we put the ultimate location it's going to as the address it's going to. Encapsulation occurs on this layer. What that says is that we're going to take the segment from the transport layer and we're going to encapsulate it inside some additional information, which is the IP address information, some other things like checksum and some things that we'll add on to it. Routing is what is occurring with the network layer of going from router to router as we travel along the distance. And then decapsulation, or as they call it, de-encapsulation in this book. Most other books I've always seen called it decapsulation, but for some reason they chose de-encapsulation as opposed to decapsulation, but they use both terms. Is when it gets to the ultimate location that it's going to strip off the header information and then pass the segment that it had encapsulated up to the transport layer. The protocols we're going to work with on this layer, the book mentions to you 5 of them. 4 of them are the ones you really need to be concerned with, but I'll mention the 5th one to you also. The Internet Protocol is the 2 that you're going to use the most often. IP version 4 is the one that's most used out there in the world today, but we're rapidly changing to IP version 6. And I'll come back later in a little bit about IP version 4 and IP version 6 on those, but those are going to be the 2 most commonly used protocols on this layer. Novell had its own protocol for this layer, which they called IPX, and you'll notice the Novell ones end in X, although now Novell uses from Novell version 5 on has used IP as their main protocol and not their IP version 4 anymore. AppleTalk was the one that Apple used on their machines and their networks, and notice it has the word Apple and it also has the word talk in it. Apple ones quite often had the word talk in their protocols. However, they're using IP now also. And then they mentioned CLNS, which was DECNEX 1, Connectionless Network Service. I doubt very seriously you'll ever see that one out there on anything, and probably never mentioned anywhere else except in this book. The only place I've seen it mentioned is in this book and the previous version of the book. It is a telecommunications one, and we're talking about computing network ones. So it's not really one you're going to be dealing with. Internet Protocol, or IP, has some basic characteristics. The first one is it's connectionless. What that says is that we're going to send stuff using IP without knowing if there's anything at the other end. Again, to use the post office example, you go to mail a letter. You stick it in the mailbox, and you've put an address on that envelope, but there is nothing definite that when it's put in the mailbox it says that address actually exists. So we didn't establish communication with the destination before we started sending the letter, in the case of IP, for sending the packets. Another one to think about connection oriented would be as opposite, would be like a telephone call. Before you start talking on the telephone, you wait for the person to answer at the other end so you know you have reached the other source before you have a conversation with that. So that one is connection oriented versus connectionless, which is how IP is working. It is best effort, and what that says is it's unreliable. It says packet delivery is not guaranteed, same as mailing a letter. There's no guarantee the letter is going to get there. You're hoping it gets there. Post office says they make the best effort to get it to where it's going to, but it's not guaranteed. In the case of the post office, you could turn there and get a registered letter instead. Register it, pay them more money, and get guaranteed that it's going to be delivered and be told that it got delivered and the receipt back saying it was received. The third one about IP is it is media independent, and that's versus the other protocols we mentioned a moment ago, is that it's independent totally of the media. IP will work on any type of media out there. IP will travel across wire, twisted pair, coax. It'll travel across wireless. It'll travel across fiber optic. Any types that we've got, IP will work on there. So it's not dependent on a certain type of media either. And so it works quite well on that, in that when you send something across using IP, it very well may go using all three types of physical media we just mentioned. There is a limit on different types of media on the size the packet can be. If it gets to a media that requires it to be smaller, it'll segment it again and break it down further, which is called fragmentation, to get it down into the smaller pieces there. The IP version 4 packet has several things in the header that they mentioned to you, types of things to be aware of. The version is included in it, so it tells it that it is an IP version 4 packet. Differentiated services, used to be called type of service, just decides the priority of the packet. That's not used very often out there. The time to live is an important one to catch right here. Time to live says that when we put the packet out there on the wire, we put a value in time to live. 15 is a number that used to be used. 31 is usually the number used on it now for the time to live. Now, how time to live works is every time it touches a router along the way, it will subtract 1 off